Okay, so today we're going to talk about 10.2, the ellipse and the hyperbola. And we're not going to go too crazy into each of these. These will both be kind of a light topic. We'll kind of see how to work with the standard form, work with the one centered at 0, 0, and then, do a little bit of shifting and so on. But we're not going to do anything too crazy with these. If you guys go on to the college algebra, you'll spend another couple sections on these and you'll learn more about the focus and the directrix. Well, that's for parabolas, I'm sorry, but you'll learn more about the focus and everything like that. So the first thing, we're going to define and graph ellipses. We're going to define and graph hyperbolas. So that's the main section. So an ellipse can be thought of as a set of points in a plane such that the sum of the distances of the points from two fixed points is constant. Okay, so each of these two fixed points is called a focus. So I was taught in one of my classes a long time ago by one of my instructors that you could technically take two nails and put them in a board like that, so you could have this nail here and this nail here, and then you could get a string that's tied in a knot, so it's like a circle. And so you would have it kind of taut right here. And then the string would be like, let's say like that. And then you would just drag it around and you would keep it tight. So what you would end up doing is you would end up creating something called, just depending on the length, I can't draw it all as you can see, but you would get something called an ellipse. Okay. So these are called the focus, or foci for plural. Okay. And that's how you could build it. This would be the center of the ellipse, the distance midpoint of these two foci. Okay, so that's basically how you could build one yourself if you wanted. It's just kind of a cool shape that you could build like that with a piece of string and two nails and a board. But we're going to focus more on the finding the center and graphing it. And again, we're going to do kind of the basics of an ellipse and the basics of a hyperbola. Okay, so we have an ellipse that is centered at 0, 0. So this would be the most basic of ellipse. Okay, where you have x squared over a squared plus y squared over b squared equals to 1. So the key with an ellipse is you want it equal to 1. Remember, with circles, it could be equal to 1, that's fine, but we didn't need it to be equal to 1. But with circles, these numbers in the denominator were not the same, or with circles, they would be the same. So normally they'd be 1, or, you might see a homework problem where it would be like they'd both be a 4 or something like that. So, I mean, I guess you could say an ellipse with the same denominator in both of these would technically just be a circle. Okay. But again, don't overthink it like that. The one thing is, for an ellipse, because this is an addition sign, we don't really care if the A is here and the B is here or vice versa. What we care about is which one is larger. Okay, so like if this were 3 squared and this were 4 squared, then the y-axis would be the major axis and the x-axis would be the minor. So, and you'll see when you graph it, it'll make a lot of sense, okay? So they say that the center would be 0, 0 because there's nothing up here with the x squared or the y squared in the numerator, okay? The x-intercepts are a comma 0 and negative a comma 0. But again, you'll see that even if it's not centered at 0, 0, it's still, usually pretty nice to find the x-intercepts. It's not super easy all the time, but it's not too bad. And the y-intercepts are 0b and 0 negative b. And again, this is if it's centered at 0, 0, like right here. Okay, so let's look at this basic one. All right, so we see that a is 4. So I'll write it over here on the side. X squared over 4 plus y squared over 9 equals 1. So notice these are different. Okay, and it's equal to 1. So this is in our standard form. We have our x squared and we have our y squared, so we're good. So what we do now is we need to rewrite these. X squared over 2 squared plus y squared over 3 squared equals 1. Okay, so what we're going to do is, in relation to the x, we're going to start here at 0, 0. So we know our center is 0, comma 0. Okay, and we're going to walk to the right 2 and to the left 2 because this is 2 squared. So I'm going to go 1, 2, and put a point. Right? I guess I don't need those two. So I'm going to walk 1, 2, and put a point. Then I'm going to go left 1, 2, and put a point. Okay, so I'm just trying to show you how they got their graph. Now for the y, because the y is 3 squared, we're going to walk up 1, 2, 3, and we're going to walk down 1, 2, 3. And then we connect the dots and we get our ellipse. So notice in this section, we're not really spending too much time on the foci. Okay. Again, that will be in the next class you take. They'll spend a lot more time talking about the foci and you know, how you can also work with that and the formulas for that. We're not going to spend too much time on that. For us, we just kind of know the foci will be like here somewhere and here somewhere. Okay, because they'll be equidistant from on the major axis. But again, we're not going to go too crazy into that. So this will be 2 and this will be 3. The center is 0, 0. Okay. So now if you look on the x-intercepts, we can see that the x-intercepts are pretty obvious. Okay. So this is -2, 0 and 2, 0. The y-intercepts once again are pretty obvious. This would be 0, 3 and 0, -3. So yes, you could memorize this and, you know, memorize the x-intercepts, but normally you can obviously see from your graph what you're getting yourself into. Okay. And again, that's what this section is about, is learning how to graph them by hand from scratch. And, you know, not dealing with the overly complicated problems. Now let's see how they got this graph of an ellipse. Okay. So let's take a look at this. Well, first thing we notice is this is not a 1, and there is a plus sign in the middle. So that's a good positive sign. Okay. So this is probably an ellipse, but in order for this to be a 1, I have to divide this by 36, this by 36, and this by 36. So that's going to leave me with x squared over 9 plus y squared over 4 equals 1. Okay, so when we do this, once again, we want to rewrite it. So this would be 3 squared plus y squared over 2 squared equals 1. So notice once again, now this time the x has the bigger value. So the x is now going to be the major axis. So I'm going to walk to the right on the x-axis. Oh, and once again, you know, this is, if you want to think about it, this is x minus 0 squared, and this is y minus 0 squared, right? So once again, the center is at 0, 0, because there's nothing up there with the numerators. So we have a center of 0, 0. We have, let's see, we're going to go over 3, 1, 2, 3, put a point. Over to the left, 1, 2, 3, put a point. We're going to go up 1, 2, and we're going to go down 1, 2. And then we connect the dots. And this is how they drew their ellipse. Okay, and again, I'm just getting this information from right here and here, from our A and from our B. And you can once again see that this is the x-intercept. So it would be -3, 0. This would be the other x-intercept. This would be 3, 0. This would be 0, 2 for the y-intercept. And this would be 0, -2 for the y-intercept. So it's like I said, once again, it's pretty straightforward. Kind of the key for us was to recognize, because this wasn't 1, we had to divide by it. And because these numbers were not the same, our A and B are not identical, it's not a circle. So a couple things we really want to pay attention to is we need a 1 over here, and we need a plus sign in the middle, and then we need these numbers to be different. Okay, the 9 and the 4, or whatever it may be from problem to problem. Okay, so now let's work with a circle that is in standard form, but the center is h, k. So again, everything's going to work just like before. So when we were dealing with parabolas, when we're dealing with circles, remember this told you how much to shift it. Okay, but everything else is going to behave the same of what we're used to working with. So let's look at this third example. Okay, so let's see how they got this picture this time. So what do we notice right off the bat? Well, we notice that this could be 3 squared. We notice this could be 4 squared, and this is 1, which is good. So we don't have to divide by anything. So I know instantly, you know what, I didn't leave myself enough room. So let's put center right here. I know instantly that my center is taken from here and from here. Remember, it said h, k. Okay, so here's my h, here's my k. Just like before with parabolas, just like before with circles, we take the opposite sign. So this would be 1, +3. So that's how they went over 1 and up 1, 2, 3. That's how they got their center. That's 1, 3. That's their center. Okay. So now from there, they now are going to use their A and B. So which one's the major and which one's the minor? So right here, we see 3 is smaller than 4. So that means the y-axis is going to be the bigger. We're going to go up 4. So I'm going to go 1, 2, 3, 4. And I'm going to go down 1, 2, 3, 4. So it feels very similar to a circle, actually. Then I'm going to go 1, 2, 3, put a point. And I'm going to go negative 1, 2, 3, put a point. And again, I just got that from here. All right. So now we see that if I just draw these lines, I connect the dots. Okay. So once again, it's not too bad. Okay. We don't, how do I say this? We don't want to overcomplicate it right now. Now, you know, if the problems get worse, you know, you could end up completing the square or something like that. But again, in this course, we're kind of just going to stick to some of the basics. There might be one in your homework where you have to complete the square, but in general, this will be kind of what you're working with. We're just trying to get an intro into ellipse and hyperbola in this course. Now, hyperbola is a little different. A hyperbola is a set of points in a plane such that for each point in the set, the absolute value of the difference of the distances from two fixed points is constant. Once again, those two fixed points are called focus or foci. The point midway between them is called the center. So again, for our class, we're going to really focus, I shouldn't say focus, we're going to really concentrate more on the center and how to graph it. Okay. So once again, standard form. However, you notice that right here, we have a negative sign. We still have it equal to 1, but right here we have I'm sorry, not our minus sign, not our equal sign. We have a minus sign right here. So we still have equals to 1, but this time, instead of having a plus like circle and ellipse have, this time we have a minus sign. That is kind of a telltale sign of a hyperbola. Okay, so I'm going to show you how I learned to graph it. The book might have a bunch of different ways, but I'm going to show you how I learned to graph it. Okay, so I learned to graph it with something called the asymptotes. And you see this little box right here? This rectangular box is how I learned to graph hyperbolas. Okay, so I'm going to kind of show you guys. And again, we're not going to spend too much time on this other than learning how to graph it from scratch, how to find the asymptotes, and how to build this rectangle. Okay, so let's see here. So first things first, we notice that this could be x squared over 3 squared minus y squared over 6 squared. Now we know it's equal to 1, okay? So now here's the big deal, okay? So if the y is in front of the minus sign, then it is going to be an up and down facing parabola. If the x is in front of the minus sign, so it's x squared minus the y squared, then it will be a side-to-side parabola. So that's how you can tell. So I guess we could call this a vertical, even though that's not really exactly how you would describe it, vertical. Did I say parabola? Hyperbola. And then if we had x squared over a squared minus y squared over b squared equals 1, this would be called a horizontal hyperbola. Let me see. I thought that they had this in the notes, but maybe they don't do it. Yeah, they don't. They do it for the other one, but not for the base one. Okay. So I'm going to show you the asymptotes. I'm going to show you how you find them and everything like that. So what we do is let's take our drawing. Oops, that's pretty bad. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So what I'm going to do now is I'm going to draw this invisible rectangle. Now, remember, this rectangle is not part of the actual graph. This is not the hyperbola, but this is a guide that we use to help us draw our hyperbola. So what I'm going to do is I'm going to use these values just like I would with the ellipse from the center. So here's our center. And I'm going to walk over 3. 1, 2, 3. 1, 2, 3. And I'm going to put points right here. Okay. And then I'm going to walk up 6. 1, 2, 3, 4, 5, 6. Put a point here. 1, 2, 3, 4, 5, 6. And once again, I want you to remember all this stuff in blue. This is not actually part of the graph. This is like our template. This is like our guide to help us draw the actual graph of a hyperbola. And what we're going to do is we're going to draw and kind of connect this. And the reason we draw it in dotted lines is so everybody knows this isn't actually part of the graph. Okay. Now, what we do now is we take and connect this corner here and this corner here, and we make an asymptote right through the center, right through the diagonal. Okay. And then we do the same with the other one. We just go right through the center and we just make these 2 diagonals. So this is how you can create your graph. This is how I was taught how to do it many, many years ago. Okay. And we now have our asymptotes. Now, because the X came first, okay, because the X came first, this is going to be a sideways parabola. Okay. So now I'm going to draw it in black. Yeah, let's do gray. So I'm going to do something like this. And remember, these are asymptotes, so I'm not really supposed to be touching these lines, these diagonals. These are asymptotes, okay? I'm just doing the best I can to try to draw it. Okay. So only the gray is the actual graph, okay? So the actual graph of a hyperbola is this gray shape right here. This is what a hyperbola looks like. But all of the blue, all of this box is what we use to give us a guide on how to draw it, okay? So this is how you can draw a hyperbola, okay? So, and it's a sideways facing one or a horizontal hyperbola because the X came first, okay? So here's a little bit better drawing of it. Now notice they didn't draw the box, but that's because they're using a computer program. The computer program can draw the box. See, I'll fill it in right here. This is exactly what we did, right? And see here, they have their asymptotes right here. Okay, so they have their asymptotes. So let me follow up with my notes real quick. So we see that the x-intercepts, if we wanted them, so the x-intercepts, if we needed them, would be at -3, 0, and +3, 0. Kind of has a very similar feel to what the ellipse would do, right? And then we also have the y-intercepts would be none. It doesn't cross the y-axis, right? So none. All right, now if it was the other way, if it was the y squared first minus the x squared, then you would have y-intercepts, but you would not have x-intercepts. I mean, that's if it's centered at 0, 0. Notice here's the center right here. If they adjust it and we do shifts and stuff, well, then you can have different types of x and y-intercepts. So the asymptotes, oops. So the asymptotes, so I don't think for our book, they want us to go too crazy into asymptotes. To sketch the asymptotes, draw a rectangle with these vertices. So yeah, so for our class, we're not going to go too heavily. In my college algebra class, I know that I'm asked to show students how to find the asymptotes using y equals, the formula, I think it's like a over x, depending on which side it is. I'm sorry, a over b, depending on where it's at. But for these asymptotes, they just want to know the corner. So I don't really think that's too big a deal. I think you guys could all plot these points and find these corners. So that's for our class, that's all they want. Like I said, if you guys go on to college algebra, which would be math 101, you'll be asked to find the foci, and also find the equation for the asymptotes. But for us, we're just kind of an intro into this. We want to learn what a hyperbola looks like and how to draw one, okay? So now, once again, these will be ones that are not centered at 0, 0. So these will be hyperbolas that are not centered at 0, 0. They'll be centered at h comma k and k, still h comma k, actually. Okay, so let's look at this. Oops, they did not give us one. Okay, so let me find one for you real quick. So we can work with this example. Let's see. I think actually your book doesn't have too many that are centered somewhere else. Okay, so yeah, I think we're actually done then, you guys. Honestly, I thought I picked a few homework problems, but this will be it for your course. I think I must be getting it confused with my college algebra course that I teach. So just to let you guys know, you could do the same thing. So if I have a hyperbola like this, and I had x minus 2 squared over, well, let's do y. Let's do y minus 2 squared over 4 and minus x plus 1 squared over 9. And let's say this equals 1. So we know that this is really 2 squared and this is really 3 squared. So let's try to test out and see if we can make one of these. So let's see here. So the first thing we want to do is we want to double check we have it equal to 1, right? We have a the y squared is first, so we know this is going to be an up and down or a vertical hyperbola, and we have a minus sign. So let's do, we have a center of 1, negative 1 comma 2. So this is my y coordinate, or I'm sorry, this is where I'm getting my y coordinate from, and this is where I'm getting my x coordinate from. Okay, so let's see here. Let's move it to the left, negative 1, and then let's move it up, positive 2. So that is my center, okay? Now from there, we want to go up 2. So 1, 2. You know, let me put this in red. So this will be up 2, and then we'll go down 2, 1, 2. And then we'll go to the right 3. So 1, 2, 3. And to the left, 1, 2, 3. Okay, so let me just kind of fill this in a little bit. 1, 2, 3. 1, 2, 3. Okay, so now I can draw this little box. And again, I just made this one up because I didn't have a good one from your homework. Okay, now we're going to draw our asymptotes through the center. And then let's go here. Okay, so there's our asymptotes right there. And now let's draw our actual parabola. Now, because the y was first, it's going to be facing like this. So we're going to do that. I didn't draw that too good, but I think you guys get the idea. Okay, so we have something like that, and that would be our hyperbola. So once again, remember that we're just doing an intro into these topics. So we're not going to get too fancy. It's more about identifying it, knowing what are the key factors to look for. But you will learn more about these in the next math class if you choose to take college algebra. Okay, you guys, I think that's going to do it for that. I don't think I made the homework too long. A little bit of it is about identifying. But other than that, you should be good. Thanks for watching, you guys.